The fastest feedback loop you have is when you're writing code locally. So what if you can put the cloud inside of that feedback loop and have this ability to run things like super quickly, and then when you're done, you just deploy it.
Hey, before we get started, I'd like to remind you that the full episode is only available to our subscribers. The current platforms you can subscribe on are YouTube, Spotify, Apple, and Patreon. And with that, let's get on to the episode. Hello, welcome to the devtools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. Our guest today is Erik Bernhardsson. Erik is the CEO of Modal Labs, which we're really excited to talk about. Before that, led engineering at Better, and before that, had a big sprint at Spotify. But Erik, before we start, would you like to tell our listeners a little bit more about yourself?
Yeah, sure. And it's great to be here, by the way. So I've been coding for, I don't know how many years, 30 plus. Started back in 90s on a Mac Plus. Like you mentioned, in particular, I was at Spotify for almost 7 years. Built the music recommendation system there and ran data teams and machine learning teams. I was a CTO for a number of years at Better. And then the last 3 years, I've been building my own startup, Modal Labs. That's my very condensed story.
So, did you yourself build the music recommendation system at Spotify?
Yeah, I mean, I left 8 years ago, and there's been a lot of work since then. And B, towards the end when I was there, I had a team of about 30 people. But yeah, I mean, initially I built the first version and scaled it up, and then started getting help when people saw potential in what I was building.
Pretty cool. So let's just jump right into Modal, since that's what you've been working on lately. So for our listeners who don't know, how would you pitch Modal to us?
Yeah, Modal is a tool for data teams, and I'm a little nebulous about what data teams mean, but people who work with machine learning, AI, or also kind of compute intensive things, or building data pipelines, or cron jobs or whatever. And Modal helps you deal with all the infrastructure, so you don't have to think about provisioning and resource management and scaling. Basically, just describe your code as normal Python. And then Modal takes that code and executes it in the cloud. And it's essentially, we are a cloud provider in the sense that we execute it on our platform, and then we charge per usage. So it's sort of a serverless platform, sort of in the style of AWS Lambda, but more targeted towards what data teams need.
So why did you start it? Was working with data and working in this fashion hard to do? Is there a lot of infrastructure to set up if you want to do these types of data processing stuff?
Yeah, totally. I mean, I've been working with data since most of my professional career, so 15 plus years. And to some extent, purely selfishly, I always wanted to have a better tool. I almost wanted to build a better tool for myself. I always felt that there's so much stuff where the most of the complexity is less about actually building a prototype that works locally. It's getting it into production, right? And there's so much stuff around scaling and scheduling and stuff where it just gets in the way of delivering value. And as well as the rest of the data stack, frankly. There's also a lot of stuff higher up, thinking at Spotify in particular, I built a workflow, an orchestrator / a workflow scheduler called Luigi. So I've also spent a lot of time higher up in the stack and thought a lot about different data frameworks and tools and systems. And what I realized was a lot of that stuff is fairly fragmented. Data teams spend so much time on infrastructure. Eventually, most companies, once they get big enough, they end up building their own data platforms, which is often a thin wrapper around Kubernetes. And then data teams are usually not happy with that because it doesn't let them do a lot of the stuff they want to do. In particular, now, I think that's very clear with GPU stuff. It's getting very hard often for data teams to iterate based on the existing platforms. So I wanted to rethink the entire data stack. I realized the best place to do that is really in the runtime layer. What I mean by runtime is building the cloud infrastructure that executes code. Essentially building almost a Kubernetes that's cloud native and focuses on the types of needs that data teams have. It's serverless, it scales up and down, it does, builds containers very quickly, enables you to have a very fast feedback loop. So I started building it about 3 years ago, end of 2020. Pretty quickly realized I was this is a deep technical problem. I have to go deep down in file systems and Linux and containers and what else is I can't do this on top of Docker and Kubernetes. So I'm gonna have to rebuild all of that stuff. And everyone thought it was crazy for saying this back then. But I realized actually like these things, like you can do this, like it just takes time. There's a lot of work, but you can have to, you can't go, someone built Docker. So clearly like, I can also build something equivalent. So started dabbling with that and pretty quickly realized like, this is what I want to do. Like this is what I want to turn into startup and started hiring people in 2021. And now we're still relatively small. We're still 10 people, but definitely starting to feel like, what we're building makes sense.
So is it fair to say that like a lot of those infrastructural problems that you were seeing in your past experience or other companies are going through, it's like you want to solve a lot of those problems and just sort of give a nice sort of runtime layer for people to sort of dive into and I guess get a lot of those benefits?
Yeah, totally. And like I think like a couple of examples would be like, let's say you're like building a machine learning some inference, like an inference endpoint. Like you have some model you want to productionize, like often like you can get that working pretty easily locally. Actually, it's not that easy these days with GPUs. But even, like once you get it working, then often like you have to rewrite everything or like rewrite like a ton of it in order to get it working in the cloud, right? And so I think there's this like huge like, chasm between like getting things running locally and getting things running in production. It's gotten a little bit better with containers, but in order to work with containers, now you need to introduce containers into your workflow. It's kind of annoying to have to like rebuild Docker containers all the time to run things. Like a lot of the like stuff we've done in the last like 5-10 years with infrastructure has like, maybe, enabled us to like bridge the gaps between local and production a little bit more. But it's actually made the like feedback loops like much worse. Like, like in the sense that like, like a couple of decades ago, I used to use like SSH into machine, like write code. And like when I was done, I just copy it into the production folder and like stuff like that. And like, I think there's something to be said about the feedback loops that you had, when the production and cloud was the same. And so like, to me, like my starting point was like, I want to make data teams really productive. Like, and I want them to not have to think about this like production versus a cloud. So what if I can like take the local development and put the cloud inside of it, like that loop when you're writing code. Like I always thought that like, if you want to think about like developer productivity, best way to understand developer productivity is in terms of these like feedback loops. Like you have this like, feedback loops and the fastest feedback loop you have is when you're writing code locally. So what if you can put the cloud inside of that feedback loop and have this ability to like, run things like super quickly. And then when you're done, you just deploy it because it's all like built in a way where like it runs in the cloud already. And that's what I was like realizing that's the key to supercharging developer productivity, specifically with like data tools.
Yeah, I've I'm not much of a data engineer myself, but I've been building some products that need GPUs and like you're right, like setting it all up locally is tough, but then setting it all up in the cloud is like a second level of toughness. And what you guys have done with Modal, the DX is just like super nice. It's like instead of hopping between multiple YAML files and worrying about my infrastructure, I just write one file, define it all in one place.
Yeah.
Totally. So the DX is amazing.
Yeah, it's zero YAML at Modal. There's like, in fact, there's zero configuration. It's all code, and that's very intentional. That because like, and that's a promise I can make to all the listeners and all the users of Modal. There will never be a single line of YAML in Modal.
Yeah, so let's dig into that a little bit. So like my first example is like Docker. So usually you have to create a Docker file and all of this. How does setting up your Docker instance in Modal work?
I mean, you don't use Docker. So in Modal, you basically describe the infrastructure inside the code itself. And I think this is not necessarily like a novel idea. Like there are some interesting frameworks that do similar things. Like in particular, like we use Pulumi at Modal. And I think Pulumi is kind of interesting in a sense. Like it's like, I don't know, Pulumi, for people who don't know, it's basically like Terraform, but it's like programmable, so it's all like code. And like when I started using it, it like blew my mind. The idea is like really, really, Pulumi has other issues, but like, the core idea is like very solid. Like you just like write code and define, like you can write like for loops and functions that like, create like Route 53, whatever. So I wanted to have something similar like inside the code itself. But then like the step further is like, I also want to put the app code inside of it too. I think like there's a couple of like AWS frameworks that do like CDK and like Chalice and a few ones. Sort of the same idea. And I think there's some Lambda-based frameworks. But anyway, the idea with Modal is like you just write code, like Python. We focus on Python. And the benefit of data teams is like 99% of it is Python. And inside the code itself, you just define the environments, but you also write the functions. And then, if you have a bunch of different functions running in different containers, they can just call each other just like normal Python functions. You don't have to think about, okay, like this stuff is running here, and then I have to like serialize this and invoke this other thing. Like it's just like a function call, like it's internally. So you can build this application inside Modal, just like one single Python script or multiple scripts or whatever, multiple modules, and define all the different dependencies, all the containerization on a functional level, and then have all these like functions calling each other, mapping over each other. And then when you execute that, the model itself builds the necessary containers lazily if needed, and then schedules everything. Scales up and down containers as needed, and executes it and streams back the output right to your local laptop. Like you don't have to there's this like AWS feedback loop where you like have to like build a Docker container, push it to the cloud, then go into like console and click a button, and then it like runs, and then when it's done you have to download the logs, and then you like look at the logs and you're like, shit, okay, like I forgot to like add a whatever semicolon on this line, right? Okay, I have to start over, right? So whereas like in Modal, it's all just like run the script, and then it like prints the output, and so you have this like very fast feedback loop, and with like I mentioned, zero configuration. It's all like a single script.
Yeah, the feedback loop is really nice. For the thing I was building, I was trying out like Hugging Face's inference endpoints, and I just found like I was waiting like 10 minutes to build Docker every time. But with Modal, like as I change my containerization layer, it does that little bit of extra evaluation it needs to, and then the next time I run the script, it's just like super quick, and I'm like in the problem space.
Yeah, totally. And Modal lets you deploy code in a couple of seconds. And if you need to rebuild a container, even that only adds typically like 10 seconds for like installing a Python package or whatever. So we really thought about it from the point of view, like we want to have this like fast feedback loops. Like we want to have this like developer experience that feels magical. Like you want to, it's like you want it to feel like, oh, is this even running in the cloud? Like, did it actually run? Like I want people to not believe it when they see it. I don't know if we're quite yet there, because there is a little bit of like a noticeable delay. Like it's not quite as fast as running things locally, but we'll get there.
Yeah, this we a while back now we had the creator of Unison on, and it has a very similar feel to me, where it's like making the cloud and calling things outside of your computer feel like it's just local. Like there is no like communication layer between my client and my server. It's just code all the way.
Yeah, totally. Yeah, I looked a little bit at Unison. I think it's super interesting. I think the difference between Modal is like with Modal, it's like you get that, but to some extent also like you get the normal Python environment, like all the libraries, like all the normal stuff you're used to, right? And I think it's a big ask to ask people to move to a new programming language. Whereas like with Modal, it's like it is the same Python you're always familiar with. It's the same IDE. Like you run code the same way almost. Like but you can actually run it in the cloud, and we deal with all the scaling and all that other stuff.
Something interesting about the sort of data ecosystem, or at least like developing in Python these days, feels a little bit more fragmented probably than it ever has, to me at least. I haven't actively done a lot of Python in a long time, but so when folks are using Modal, is it sort of a bring your own tools? Because there's like a plethora of package management solution for Python, for example. And you said you're doing a lot of the stuff on the cloud as sort of a really tight feedback loop. So I'm assuming that when you're specifying packages, you're doing that through some light DSL wrapper inside of your configuration files. It's like, hey, I have these dependencies that this function needs.
Configuration files.
Well, I mean, like in your actual runtime code, you're talking about how it's like, like this DSL that's like alongside your function. So it's like, we give you the tools that you need for doing things like dependency and everything else, and then it's just like, you just write this function and then it's good? Or is it more like, here's how you slot into your other workflow? You're using, I don't know, poetry or whatever.
Yeah, I mean, we tend to just like push people into using like pip. I tend to think pip is like, it's like the only thing that I've used that like generally works. But I think the other benefit is also like in the cloud, like we build everything from scratch. And so like it's sort of less of a problem. I tend to think like the big problem with Python is always like when you have a bunch of different virtual environments like locally, and you have to reconcile different stuff. And like, but whereas like I think the like dumb approach of like just create a new virtual environment for everything kind of works, or like let's just build a new container for everything, that also kind of works. And if you do that, it's actually less critical which package framework you're using. I tend to use pip most of the time because it's like the most commonly used one. It's like well understood. We do support other ones too. Like in theory, like a bunch of people use Conda with Modal. You could in theory use Poetry. We have some basic support for Poetry too.
So, what are the primitives that Modal provides to help you like build up these things? Like, how do you define one of these cloud functions?
You just write a normal Python function, and then you apply a decorator, and in that decorator you define the runtime environment. So that's like basically what image it is. And you can also define things like, do you need a GPU? Then you specify what GPU type. There's a bunch of other stuff. Like you can add like a cron syntax if you want to, like, you want the function to be automatically triggered certain times a day, or you can actually mount like file systems to it. So we have this ability in Modal to define essentially like an NFS equivalent and mount that to the containers locally, so you can set up like shared file systems and a few other different things. And then those functions are just normal Python functions, right? And you can in those functions you can call other functions. You can map over other functions, and then we automatically scale out. A couple of other things you can do, like you can set up secrets. So you can set up in the web interface in Modal, you can define like credentials, your AWS credentials or OpenAI keys or whatever. And then you can import them in Modal. You can annotate functions and say, I want to inject these as environment variables, and then you get them available as just as environment variables in runtime. So this way you don't have to like deal with hard-coded secrets in code. You just inject them in the cloud. What else? You can define things to be a webhook. So you can take a function in Modal and basically annotate it as, I want this to be a public webhook that's exposed to the world. And then Modal will then generate a random or a unique URL that you can then go to, and that will trigger that function. So those are some of the primitives we have in Modal. You could build quite powerful apps with.
Is this position more like a serverless framework in the sense that they're more for shorter running jobs? So you do like a shorter running process versus maybe more longer term living, maybe you're doing a really big analysis or something, sending that to a GPU. I guess like in that scenario, you might have like a server that is dedicated to this process or whatever. To reframe, is it shorter or longer running jobs that you're sort of aiming for?
I think we're like fairly unopinionated about that. Like Modal as a whole, like you can run things for up to 24 hours. But that being said, I think probably like it skews towards shorter running stuff. It tends to. I think the main reason is probably like one of the benefits of running things serverlessly is really cost. Like when you have, when you can auto scale to the actual usage. Like let's say you want to productionize a machine learning model and you don't know how much traffic you're going to get, right? Like with a traditional system like Kubernetes, like you essentially have to like. The system scales quite slowly, right? Like it doesn't scale within seconds. So you have to provision to some extent for peak capacity, right? Which means you can have like pretty low utilization rate. So where I think we've done like right now, where we see by far the most usage is like deploying Gen AI, like GPU based models. Like GPUs are also expensive. So that's the other thing, right? Like people want to save money by running serverlessly. And so that I think that's like one of the biggest benefits that's evident with Modal right now is like people see, a lot of people may actually move from EC2 to Modal and end up saving a lot of money because they have this ability to auto scale very quickly up and down usage. So for that reason, it tends to be shorter running things, like a couple of seconds, like typically like inference endpoints, like doing stable diffusion, that kind of stuff. But we have a lot of people also doing things like fine tuning is getting more and more common. So an example of fine tuning would be like Green Booth, for instance. So like you can like basically like fine tune this like custom stable diffusion model based on like pictures of you or whatever, like pictures of your kids or your dogs or whatever. And then you can generate like, stable diffusion pictures of your dog or whatever. And that fine tuning process often takes like 30 minutes. So that's something people do quite a lot with Modal. Like they'll have this like thing running for 30, 40 minutes on Modal on A100s or something like that. We also have some people doing training with Modal. So in that case, like you might actually have like things running for like several hours or days. Because I think you can actually, I said 24 hours, but I believe you can actually extend it to 7 days. I forget what our upper limit is. So we have some people running it for much longer than that. But I'd say the median is probably like 5 seconds.
Yeah, that's much longer than most other serverless platforms where you're like capped at 20 seconds. Can't do too many interesting things in 20 seconds. I think
exactly.
The auto scaling is a huge point. Like when I was comparing platforms, it's like I come from a front end JavaScript world. I have never had to run a GPU before. and running a GPU for a month all the time is like $500-$600. So
Yeah.
like the ability to like be an indie hacker and say, oh, I want to put this model somewhere and only have it spin up when I need it to spin up is super powerful.
Totally. And if it goes viral, we'll scale.
Exactly. Yeah. And I like all the features you guys have for like, oh, like maybe have this run for like 3 minutes after the last request, or keep like one or two of these always on. So it's very nice and very like flexible to the needs of the developer.
Yeah. Now the problem, I think, on the technical side, just because I think it's interesting to talk about with doing serverless GPU is the cold start, right? Because in order to do these models serverlessly, you need to spin up the containers very quickly, like on demand. Like a user request comes in, now you need to spin up a container very quickly. And that's a problem in itself just for CPU-based functions. Like Lambda has solved it clearly. Like they can spin up containers very quickly. But when you're dealing with GPU models, suddenly it's a much bigger problem, because like some of these GPU models, like just starting with Stable Diffusion, that's 5 gigabytes. So you need to take something that's 5 gigabytes large. Like with Kubernetes, it's like brutal, right? Like you need to pull down a Docker container, then like, start up the container. Then that one has to read like 5 gigabytes from network into memory, and then, copy it from memory to GPU. So that's like, a minute or two, right? But with Modal, we ended up building our own file system. We building our own container runtime, our own container image builder. And so because of that, we can do something similar in just about 10 seconds, like starting a container, loading the 5 gigabyte model files like from network into CPU memory, and then copy it from CPU memory to GPU memory. I hope to get that down to a couple of seconds eventually. There's clearly 5 seconds or 10 seconds or whatever it takes is still a long time. And it's as a noticeable latency. And it gets even worse for some of these like very large like language models, right? Like you have these language models that are like 40 gigabytes, right? But those are some of the very super interesting technical challenges we're dealing with. Is how do you load these very large models into GPU memory very quickly in a distributed system?
So do you guys like? I don't think you guys actually like own the hardware, right? Like who actually owns these GPUs?
Yeah. We didn't go that deep. We do run this on the hyperscaler, the public clouds, right? Like in particular, Oracle has good GPUs. We run this on AWS and GCP as well for some burst capacity. We haven't gone quite as deep as building our own hardware. I think that's a bridge I'm not sure if we're ever going to cross. Maybe one day, but everything down to that point, right? Like we've done a lot of just like performance tuning Linux kernels, and like there's a lot of like deep stuff that we've had to do in order to get to the performance we wanted.
Yeah, I think just working at Oxide has taught me this lesson where if you step outside of the sort of composed software and even hardware components that you're putting together and think more critically about what is the holistic problem you're trying to solve, you can often come up with solutions that are much more performant, because there are all these trade-offs at all these layers in general composable software. You got Kubernetes and you've got Docker and all these things, and they're meant for a specific use case. And, maybe this use case is non-optimal. And
I always think about this, there's modern computing has so many abstraction layers on top of abstraction layers on top of abstraction layers, right? And every abstraction layer usually adds an order of magnitude of overhead. And so why is it that when I go into AWS, computers do a billion or a trillion floating point operations a second. But when I go into AWS and I update some load balancer setting, it takes 25 minutes sometimes for it to propagate, right? Why? But I think the solution is there's so many different layers of abstraction that they're all relying on cache invalidation or TTLs or so many different things that all just add up, and that's why we end up having this slow stuff, right? But a lot of these things, if you actually push through, you can actually figure out ways to make it 100 times, 1,000 times faster than what people think. Not always, of course. I mean, there are fundamental limits. Network bandwidth is hard. Once you saturate what a network interface can do, it's hard to get around that. But a lot of stuff is how fast should a container start? I don't know. I don't see a reason why it shouldn't start in a few milliseconds.
Yeah, I mean, I think that's the beauty of building a company like Modal, where you're really looking at this problem holistically. You're all right, this is what we want to do. We want to provide this DX. We want to provide these performance guarantees and give this just general experience. And you're able to say, we don't need this, or like, let's redo this, or something that wouldn't make sense. Maybe, if you're on a team at Amazon or whatever, you're like, hey, yeah, we could remove these abstraction layers. And they're like, we could, but also we have to ship these other things, or, we're focused on these metrics this quarter or whatever,
Totally. And I think that's a big benefit of building for a particular use case or particular team, right? Like when I look at AWS, like I have tremendous respect for AWS. Like I love AWS for what it enables me to build. And I don't think we would be here without AWS, right? But like AWS, their products are like, they're trying to build for like a very large, group of people at the same time. And what that often means is that they're not really thinking through what people need. They're building, more like infrastructure and just like throwing it out there and then like hoping people pick it up. And whereas I think, something like Modal, we can actually like kind of start over and think about what data teams need. And then, I didn't end up building what is a container infrastructure because I wanted to. Like in a way, like it's like almost like building it out of spite because I got mad. But like we're doing it in the service of like building better, faster feedback loop for data teams. And like I think a lot about like, Vercel is a company I look up to a lot too, right? Like they're starting with it's a very different company, right? Like very different product. But like I think in a ssimilar way, they're starting with a problem. Like they're starting, okay, let's make like front-end engineers faster. Like let's make it easier for them to deploy things, right? And then, then they can optimize. And in a way, it's almost like repackaging the cloud in like a vertical way for a particular workflow and for a particular set of users. And I think if you make that assumption, suddenly you can like really go deep on like what those people want.
Well, that's a very interesting way to look at that. I could see many other companies popping up in that like vertical for a specific developer.
Totally. And I think to me that's been fascinating, right? And I've written a lot about it on my blog too, is that as much as I admire, I love the cloud providers, and I think AWS and the other ones have such tremendous technology. But I think like the last, the developer experience was never there, right? Like I've used AWS for 15 years and it's still hard, right? Like, deploying a Lambda and then IAM and like whatever, it's like hard, right? So I think it's been interesting to see like in the last decade or so, or the last 5 years, like there's been an emergence of what I call like a second layer of cloud providers, right? Snowflake is a good example. Datadog, Vercel, Modal, hopefully, right? Like also like Railway or like Fly or whatever. Like, and the idea is that like they kind of repackage this cloud and like offer a better developer experience. And then even though they may actually use the cloud provider under the hood, right? Like Snowflake, which is a SQL-based data warehouse, right? Like they end up using AWS under the hood and also the other cloud providers. And so the question is like, how are they able to compete with AWS? Because AWS is also trying to go up the stack and they have this Redshift thing. But I think what's been evident is like AWS does the underlying compute layer extremely well, like the EC2 and the Route 53 and like S3 and like all these things like so well. But in the layer above, like I think there's plenty of room for people to compete on developer experience and rethink what that looks like. And I could see a world where like give it a few more years, like the average engineer may not actually interact with the clouds anymore. They may interact with those tools that are layer above the clouds.
Yeah, super cool. So I want to dig a little bit deeper on some of the technologies you mentioned. Like you said, you had to rebuild the file system. Like I would never think that, I need to rebuild the file system to get this performance guarantee. So like, why did you do that?
Yeah. So first of all, like a kind of open secret is like, it's actually less hard than you think to build a file system. I mean, there's like Fuse, which is like file system user space. So you can, and there's even like a Python wrapper, or like there's a Python implementation of it. So our first prototype file system, we actually wrote in Python, which is a terrible idea, but it was great for like kind of proving the point, like it actually worked. Anyway, why did we build our own file system? So the problem is we want to start containers very quickly. How do containers start, right? Like a container is essentially, from a Linux point of view, it's basically like a couple of different primitives. There's a couple of things around resource isolation and security, but it's also a thing around defining a root file system and pointing to, here's the root file system in my Linux machine. Please start a container from this Linux file system. And what we realized is that the average container image is very large. It contains so many files that are never actually read. And so when you have this like pushing and pulling of container images, there's a lot of inefficiencies, like moving a lot of data that's never read. And also to some extent moving the same data, because like a lot of different containers, they actually contain the same data over and over. And so there's this deduplication based on layer, but that actually doesn't accomplish too much like in terms of efficiency gains. So what we realized is like, what if we instead build this file system that presents this file system to the container engine. But however, those files actually don't exist on local disk. But when the container engine runs C or something like that, it requests this file, then we go and fetch them over the network. So that way you can accomplish, just getting rid of, you don't have to copy all these files that are never actually read by the container. The other thing we realized is that a lot of the files are the same. So what if we checksum them, and instead of storing them based on path, we just store them based on the checksum? And we built essentially what's called, the idea is a well-known idea. Other people have been doing this since the 60s, content-addressed file system. So we built a content-addressed file system where we compute a checksum for every single file. We store that separately, and then we have index files that then resolve to this underlying blobs. And then we built this file system that presents that to the container runtime as it is, as a root file system. But under the hood, we actually go out and fetch the underlying blobs and then cache them locally on SSDs. And if you do a lot of these tricks, you can get very low latency container startup and very high cache efficiency, which means you can boot containers very quickly, which was the end goal that we wanted to get to.
That's super cool.
Yeah. And it once again reminds me of Unison. Me and Justin smiled at the same time.
Oh yeah, because they also have some sort of like checksum based. Yeah, I remember reading about it. Yeah, you're right. Like it's pretty interesting. Yeah, it's a content address thing. Yeah.
That's super cool. Like you basically made a lazy file system, which one of the biggest things in performance is just make things lazier, and that'll make it faster. And it seems like you guys took that to the extreme here.
Yeah, totally. It's kind of like a CDN in a way. Like we think of it as a CDN in many ways.
That's awesome. I feel like this is a space that definitely should be explored more. I've seen some really creative experiments with people just playing around with Fuse, just like building really cool stuff. And it's like, yeah, file systems are really powerful, and there's a lot of things that you could do with them potentially. And this is such a great example of that. Yeah,
totally. And our file system is proprietary, but I think there are some open source ones where people have been trying to implement this within Kubernetes and within Docker. There's a project called Nidus, and there's another project called Dragonfly, I think, something like that. Maybe it's the same thing. So there's and then there's another file system called like StarGZ or something like that. So there are some attempts to implement this within the existing sort of Kubernetes Docker realm. I don't think it's widely used, but it's sort of interesting to see like these ideas are in a way like kind of, if you actually go deeper and like think about it, like I think there's a lot of people who have sort of arrived at the same conclusions.
So I'm sure you have a lot of really interesting use cases for this. One of the delightful things about building a product like this is just seeing how customers use it. So what are some of the cool things that you've seen built with Modal?
Yeah, totally. It's funny you're asking it because like actually for the first year and a half, like we did not have like a particular use case in mind. Like we were just building this thinking like we're building a Kubernetes for data teams that's cloud native, right? And like I always had a high conviction that like this makes sense, but I didn't really know like what's the killer app or like what's the main use case. And it wasn't until last summer we started realizing like there's a lot of cool stuff happening in Gen AI. And we have a lot of the primitives that would really be valuable for that audience. Like we had GPU support, serverless, fast boot up. And so that's really where we've been seeing a lot of traction. So it tends to be a lot of the things that we see since then has been like stable diffusion, like some people generating lots of images, like basically like prompt to image generation. It's been a big use case, Stream Booth, ControlNet. We also seen a fair amount of like text to speech, speech to text. We've seen some people generating music on Modal. We've also seen a couple of people doing 3D rendering on Modal, which is kind of unexpected. I think it's funny because like you're like, oh wait, you can use like GPUs for rendering 3D, and they're like, wait a minute, like that's actually like you kind of forget that's what GPUs originally built for it. But yeah, so people use there's a bunch of people using Modal for like 3D rendering 3D images. And then we have like a couple of people doing things completely outside of AI, right? Like doing like computational biotech, like AlphaFold or like sequence alignment, that kind of stuff. Web scraping, video transcoding, like stuff like just like batch running, like FFmpeg. There's kind of a wide range of stuff that people are using it for.
Yeah, it must have been very nice when you're like, oh wow, AI, like it just popped onto the scene and kind of just like made for the perfect use case.
Totally. Yeah, and I think in hindsight, like what I think is clear now is like a year ago or so, like we built this thing we felt was like much better than Kubernetes, but I don't think it was like fundamentally like good enough for people to really like feel like, oh, I'm going to switch. It's not quite worth the switching cost. But when all this like AI stuff started happening, then I thought it was very clear that like, traditional infrastructure breaks in a big enough way where like there's now suddenly a very clear reason to switch to something new, right? And that's where we felt like we've positioned ourselves really well. But like my goal, to be clear, is not to like, be like an AI company, right? Like I love this AI stuff. I always been, working on AI stuff my whole, most of my career. But I think there's so much other stuff, right? Like there's so much other non-AI stuff. There's so much like compute intensive stuff completely outside of AI that's also like super exciting. And we want to support those things too.
Yeah, I think especially now with as much excitement and intention as there is, one of the really interesting sort of value props here is just lowering the overall barrier of entry, right? Because there's a lot of people who want to experiment, who want to like put out products, and in a traditional sort of infrastructural setup, you've got a lot of engineering investment, as you've already pointed out, just in getting started and setting this stuff up. And it's generally like mature organizations who are doing it. And, having somebody, a person or a small group of engineers who can get together and then on a weekend hack together like a proof of concept of a product because they have a fast food feedback loop, like you said, because it's like, infrastructure on demand, all of these things, really good UX, that is huge, and just enabling people to build products. So I think that's incredibly exciting.
Totally. And it's not just necessarily like lowering the barrier. Like I think that's like one side of the spectrum, right? Like you definitely want to like make it easier for people to do this. But I never wanted to build what I've been like jokingly referring to like Kubernetes for kids, like a kind of a simpler version of Kubernetes. Because I think it's really important also that you're building something that also like advanced users want to use too, right? And like for instance, like I think about myself, right? Like I understand AWS really well. Like I understand Docker, Terraform, like all these tools, right? Like I've been using it for like 15 plus years. But like even to me, like gets in the way of like delivering value. Like I want to write code. Like I don't want to write YAML. I want to write code and like build cool applications and ship them, right? So to me, like the best tools has always been the tools that sort of appeal to both sides of the spectrum. Both the people are like starting to dabble with something new and like, and then they're like, oh, this is really easy to get started with. But also the people that are really into like, have all this deep expertise and they're like, this is like getting in the way of like me like doing stuff. Like I just want to like do stuff, right? So that to me is like, this design, like that's a tool I always wanted to build. It's like, you appeal to a very wide range of users.
For sure. I mean, I feel like this goes back to, it's all really related to the same thing. It's the layers of abstraction just introduce a lot of incidental complexity. It's like, we don't intend to spend all of our time, tuning Kubernetes, but we end up doing it because we have to do it to get, whatever we want deployed. And so definitely experts or beginners or whatever. It's just like, if you don't have to deal with a bunch of configuration or whatever, it just helps you move faster.
Absolutely. Yep.
So let's look to the future a little bit. What's next for Modal? What are you guys building towards next? It seems like you have a platform that works for a lot of use cases. What are you planning on?
Yeah, I mean, we're not GA yet, generally available. Like we still have a wait list and we're growing, deliberately and intentionally, but not, open to anyone to just register. So that's the next milestone, is to get it out of GA. The main focus right now to get there is just performance and scale. Like we need to make a bunch of fundamental infrastructure investments to be ready for that scale. And also to some extent, like fixing a bunch of like minor like client stuff that's like bothering me. Like there's a few things where I need to break the SDK in a few ways where I want to do that before we launch, because I don't want to deprecate like too many people's code. But that's, I hope relatively soon, like, could be as soon as like end of the summer. It could also be like end of the year. Like, I don't quite know, like we'll sort of see. But to me, that's the next milestone. And then I think a lot of it is just like scale and performance for the rest of the year. Like I mentioned, cold starting stable diffusion is on the order of 10 seconds. Like I would love to get that down to 3 seconds, but that's a hard technical investment. And probably would involve us like doing crazy stuff like snapshotting running containers and restoring memory and like snapshotting GPU. There's like getting below where we are from now is definitely hard. I think in the long run, like I think, moving outside of AI, like, we're registered in biotech, registered in like financial applications. There's a lot of interesting like, back testing and financial simulations that are pretty interesting. We tend to do really well with startups right now, but we're starting to get some enterprise customers, and that's another area I definitely want to explore further. We just got our SOC 2 compliance done, so hopefully that's a sort of starting point for getting some more enterprise customers. And then, who knows? Like, I don't know. The exciting part about Modal is like, once you build this foundational like runtime, like there's so many different directions we're going in. So we're exploring a few different, like, we're dabbling with some ideas. Like one of the ideas I'm kind of excited about, I might mention, is like, what if we could rebuild like sandboxing so like people can run like code in a safe way? There's actually a lot of our customers are running LLMs that generate code, and then they're like, we want to execute this code, but we don't want the code to hack ourselves. So like they want like a safe code execution environment. So that's like one of the like kind of proof of concept things we're like exploring with, because we have all the primitives for that. So we'll see if that, to me, that's like kind of a research project that we'll see. But we have a lot of those ideas of like, yeah, we could do this, we could do that. Like, let's try it. Like, let's see. And then, maybe some of them will work, maybe some of them won't. But to me, like where we are right now is super excited, because we have this like starting to have this like really nice, solid platform that you can build a lot of stuff on top of.
Yeah, you fooled me. I didn't realize it wasn't GA yet. Your guys' docs are great. You have so many good examples. Like me, as I said, I'm a front end developer, but I got into Modal and was productive with it within hours. So like you guys have done a very good job at communicating on the website.
That's awesome. Next year, I want to get that to minutes though. Like should take minutes for people to be productive, and then the year after should be seconds, and then milliseconds.
That wraps it up for tooltips this week. Thanks for coming on, Erik. This was a fun talk about the world of Modal and data serverless stuff, something that both me and Justin really aren't all that accustomed to, but it was fun to talk about it nonetheless. And thanks for coming on.
Awesome. It's great to be here. Thanks a lot for hosting me.
Yeah, Erik, and to just repeat what Andrew said, really awesome to have you. And also, I mean, thanks for doing this. Like, I know that this is a problem that you're like sort of nerd sniped into doing, but Modal, it provides like some real value. And this is a space that I'm excited, just to reduce that, give people an option to reduce the incidental complexity a little bit so they can build more products.
Yeah, I 100% agree. Hold up. I'm very biased, but definitely agree.